Hello, and welcome to this session recording from the AWS Summit London, focusing on infrastructure as code. My name is Stephen Bryan, and I'm a solutions architect at Amazon Web Services. I'm also joined here by Raj Wilku from JUST EAT. Before we get started, if you'd like to download the slides from this session, please check the video description for the link to the AWS SlideShare where you can view and download the slides. So, you're on board, you're listening to this talk, so my guess is that your business needs to experiment, innovate, or reduce risk, and you're probably looking at some of the tools that are described on this screen to get you to that end state. We often hear words like continuous delivery, DevOps, and cloud, and these tools can really enable you to get to a desired end state when it comes to reducing operational costs and improving the way that you run your IT in your business. This talk today will hopefully focus on some of the AWS servicing tools that will enable you to get to that desired state. And we'll hear from our customer JUST EAT at the end, who will give us a good overview of how they're doing infrastructure as code within inside their environment, so you can get an example of how it's happening in the real world. So AWS's flagship service for doing infrastructure as code is CloudFormation. Now, I know there's probably a mixed range of people listening to this talk, but I'll spend the first few minutes just introducing you to CloudFormation and giving you the basics, so please bear with me if you already know this stuff. AWS CloudFormation allows you to create templates of the infrastructure and applications you want to run on AWS. CloudFormation templates include multiple resources inside the AWS environment, all the way from EC2 instances or servers to SQS queues, S3 buckets, or even subnets inside of VPCs. It allows you to easily version control, replicate, and update the infrastructure, your infrastructure using these JSON documents templates. It also integrates with other development and continuous integration deployment tools such as Bamboo and Jenkins that enable you to integrate this with your continuous integration and continuous deployment pipelines. So let's look at an example website. This is a simple web application. We have a load balancer, some monitoring alarms there from CloudWatch. We've got our EC2 instances in an auto-scaling group, an Elasticache cluster, and some software and data sitting on top of it. This application also has to reach out to other services such as the DB service, the inventory service, and the recommendation service for this website for it to operate properly. Now, everything inside of this diagram that you see can be deployed using CloudFormation, including some of the external resources that you need to do some work as well that may or may not be outside of the AWS remit. Hopefully in this talk we'll give you a good overview of how we can use CloudFormation to both deploy AWS resources as well as configure custom resources as well. So when we look at a CloudFormation template, as I mentioned earlier, it's a JSON document. You can see the JSON syntax here. In this example here, we're creating an AWS auto-scaling group. And what this is called is a resource. A resource is one of the key parts of a CloudFormation template. And resources are things that you wish to deploy inside your AWS environment. So in this case, an auto-scaling group. This could also be an Elasticache cluster, an EC2 instance, a security group, or a firewall rule maybe. Or a load balancer. So resources are the things that you want to deploy. And as you can see from the language here, it's declarative. So we're defining what the end state should look like when this auto-scaling group is deployed. The second thing you'll need when you're creating templates, although not mandatory, are parameters. Parameters allow you to provide inputs either manually or via the APIs into your CloudFormation templates. So good examples of this might be the EC2 instance type that you want to deploy. You can set constraints around inputs, such as allowed values or which type you want them to be, whether it be a string or an integer, for example. And then you can reference these inputs elsewhere inside your CloudFormation template, so you can retrieve the values of them when you need to. And then usually at the end of our template, we'll configure some outputs, and outputs enable us to provide input back to the user after the template has been created. A common example we see here is using an ELB or an Elastic Load Balancer DNS name to provide to create an address that you can access, say, a website on, for example. You could output many other things from the template, and then you could either view these within the AWS CloudFormation console, or you can again get them programmatically using the APIs. Another part of the CloudFormation template is something called CFN Init, and this is optional. But what this allows you to do is deploy and configure software on your EC2 instances from within inside your AWS template. I won't go into too much detail now because we'll touch on this in a few slides in more detail. But basically it allows you to declaratively define packages and software and files that you want on your EC2 instances within your CloudFormation template. CloudFormation also has some nice language features that allow you to do some basic tasks, such as the join function, which will allow you to concatenate strings, which is very useful when creating those URLs for outputs of your templates, for example, and in many other cases. There's also some very useful functions here, such as get AZs, which will give you the information around the AZs within your region, etc. So you can get information around the AWS environment that this template is running in. As I mentioned earlier, this CloudFormation isn't just about deploying servers, it's about deploying your whole AWS environment. On the screen here you can see the supported services inside CloudFormation. There's more to come, but you can see that we're not just covering the core services such as EC2 and S3. We cover many other services, including things such as OpsWorks, Redshift, Elastic Load Balancing, and Elastic Beanstalk. When you see some of these services on here, they include the kind of complementary services, such as when we say Amazon EC2, that means we can deploy all of the features inside EC2, and VPC, we can deploy all of the subnets, for example, inside there. A very nice feature of CloudFormation, and something that many beginners don't really look at first, but becomes very useful down the line as your templates start to grow, is nesting CloudFormation stacks. And this is a best practice we'd like you to get into early. So this is the ability to nest multiple stacks inside a parent stack. So this example just shows a template called mystack.template, which is in an S3 bucket, but I'm able to nest that inside of an existing CloudFormation template. A good use case for this might be nesting a database and a caching stack and a web tier stack inside a parent stack that deploys your whole application end to end. This means that when you're editing your CloudFormation templates, you're not editing huge templates with hundreds of lines of JSON in them. You can reduce them down to small functional areas. One key feature here of the nested CloudFormation stack feature is that you can pass parameters into your nested stacks from your parent stack. So this might be an input parameter that's come from the parent stack that you can pass through programmatically within the syntax here into your nested stack. And these are just key value pairs of the input parameter name and then the value. Another benefit of CloudFormation is the ability to iterate on infrastructure. So let's look at that in a bit more detail. There's really two ways you can use CloudFormation to iterate on infrastructure. CloudFormation allows you to do in-place updates, so using the update stack command, and that allows you to update your template and then use the update stack API to update your stack. And what CloudFormation will do will compare your new JSON template against your existing and apply any changes to your infrastructure. This allows for very quick changes, as it only changes the delta. And it's also cost efficient because you're still just running one environment. The other option, which is very popular, is blue-green deployments, and this is updating your CloudFormation template but deploying a whole new stack from that template, and then you can flip traffic to the new template. Sometimes not all traffic. Maybe you can do split DNS to present maybe just 20% of your traffic to do split user testing. But when you're happy with the new stack, you can then tear down your old stack. This takes a little bit longer to provide updates because you have to deploy a whole new stack, but it does provide for very easy rollback if there's any errors within those updates in your stack. So if we look at extending CloudFormation, the first way we can do that is using custom resources. And I mentioned at the beginning when we described this application that there may be third-party resources that the stack may need to deploy as part of its provisioning. So in this example here, we can see that this application needs to get a tracking ID for an order, and that's being retrieved from a third-party service. You can see that we're using the custom resource feature here to speak to a third-party resource. Now, how this works is it uses the Amazon Simple Notification Service to send a notification, typically a HTTP post, with a unique S3 URL and any data that you provide to that end application. That application is seen as a custom resource, and that application needs to be able to receive that data, and then do what it needs to do, and then send a success or a failure message back to that S3 endpoint to confirm that that custom resource has been provisioned or not before continuing and deploying the stack. Very easy way to extend CloudFormation to third-party services or APIs. And a very new feature just announced last week at the San Francisco Summit is Lambda-powered custom resources. Now this is really exciting for AWS because we can now create Lambda functions, which is code in the cloud, so you only have to worry about writing your code, and AWS takes care of the infrastructure underneath that to execute custom pieces of logic inside your CloudFormation stack. So a few examples here: you may want to look up an AMI ID, you may want to look up your existing subnets inside your VPC and then get the next available subnet and then send that data back to your CloudFormation template. Many things you can do here to extend AWS CloudFormation beyond just implementing AWS resources. So if we look at we spoke a lot about infrastructure lifecycle, deploying things such as EC2 instances, auto-scaling groups and VPCs. But a big part of infrastructure as code is also your application lifecycle, installing packages and software that enable your applications to run, and updating that software and restarting applications when you've done updates, etc. CloudFormation can be used for both of these, and this is using that CloudFormation Init, or CFN Init as we'll call it, feature that I mentioned earlier. So not only can you templatize, replicate and automate your infrastructure lifecycle, you can also do the same with your application lifecycle using CFN Init. So if we look at the CFN Init syntax, you can see here that this is really a way of bootstrapping your applications and installing software, and again it's a very declarative language in the sense that you declare what you want your end state to look like. For example, you could tell CloudFormation where to look for an application source and where to install it, and CloudFormation will figure out how to do it. If you had to do this by writing scripts, you would have to think of all the different API calls and steps that would be required to deploy that software or copy that file. But when using CFN Init, CloudFormation takes care of that for you. CFN Init also supports updates as the same as the rest of the CloudFormation stack. So this allows you to update instance metadata inside of the template and then call an update stack command to update that stack, and the CloudFormation agent on that instance can then update that stack changing just the things that have changed inside your template. So again, to update say a package version, for example, you could just change the packet version in that declarative text in the CloudFormation template, and the agent will automatically update that package version on the end nodes for you. So many of you may already be using other configuration management tools or code deploy tools such as Chef or Puppet, or maybe even AWS Code Deploy. This example here shows you how you could use Chef to configure the Chef client on an EC2 instance, and then execute the knife command in Chef to execute a recipe for a WordPress install. So it's very easy to install Chef using user data, for example, but user data only runs once, so we'd recommend, even if you're using third-party configuration management tools, that you would use CFN Init to declare the initial installation of those tools, because then you still get the benefits of the update in place and the declarative language inside of the CFN Init syntax. To use CFN Init, there are three things you need to do. You need to get the latest CloudFormation helper scripts and packages by installing the AWS CFN Bootstrap package. And then you need to trigger a CFN Init configuration, which basically updates your CFN Init client with the stack reference and the region in which you're operating. And then you can signal completion. So I won't go into all the syntax on here, but you can put all of this in user data, again declared inside of your CloudFormation template. So your CloudFormation template, when you deploy an EC2 instance, has the option to provide this user data. So this is still CloudFormation syntax on how to provide a bash script to go and install these agents and configure them on your EC2 instances so they're ready to work with CFN Init. Now, debugging CFN Init, a good way to do this is to use CloudWatch Logs, a new feature of CloudWatch, and you can use CFN Init to install the AWS Logs package, as you can see here at the top of the slide. And then you can provide a file called cfnlogs.conf, which CloudWatch Logs will use, and within that you can tell it which logs to send to CloudWatch Logs. And CloudWatch Logs will then give you this nice dashboard that allows you to visualize all the logs when CFN Init is running. Now, one of the things that you can also do here without going too deep into CloudWatch Logs is you can configure filters and alarms on these logs. So, for example, if there were any error messages, you could get an alarm sent to you via an SNS notification through the alarm feature of CloudWatch Logs. So, even though you're automatically deploying your CloudFormation templates, maybe you can still be notified when something goes wrong. Another advanced feature of CloudFormation that we want to talk about are wait conditions. One thing we'll also talk about is depends on, but we'll use one example to cover both of these. So this is a very simple CloudFormation resource called EC2 instance that we're deploying, and what we're doing is we're passing some user data, so some arbitrary data to this instance. The user data is available via the EC2 metadata service, so the instance itself can view this data once it's launched. This user data we're passing here is a reference to another CloudFormation resource called myWaitHandle, which is part of the wait condition, which we'll see on the next slide. You can see here we've defined the wait handle and then a wait condition. What we've got here is a wait condition that depends on this EC2 instance resource. What this means is that this wait condition will not trigger until the EC2 instance is fully provisioned. And then you can see the timeout here. This wait condition will wait 4,500 seconds before rolling back the stack if it doesn't have a success signal back back to its API. So when we pass that reference through to the user data, what that does is that wait handle passes a pre-signed URL that the EC2 instance can then use once it's done what it needs to do. So if you need your EC2 instance to maybe go and do some updates, or you need something to happen on that EC2 instance before you need to continue with deploying that CloudFormation stack, what this wait condition will do, will wait 4,500 seconds, and during that time you will get your EC2 instance to do what it needs to do, and when it's finished, grab that pre-signed URL from the metadata and use curl or some other tool to send a response back to say, we have successfully finished our work, please continue with your stack. And again, if that 4,500 seconds lapses, the whole stack will roll back, so it's dependent on this wait condition completing successfully. And the final thing I'd like to touch on is continuous integration and continuous deployment pipelines. CloudFormation is often used by our customers in their CI and CD pipelines. You can see this typical workflow here of an issue tracker, developers working on some code, pushing that code into a code repo, and then the CI server deploying that code into maybe test, then stage, and then prod using continuous deployment. We'd like to think that you can use CloudFormation to do the same with your infrastructure. So using exactly this same workflow to use your continuous integration or continuous deployments pipeline to deploy your infrastructure using CloudFormation as well. So really we want you to think about deploying your infrastructure as code and managing it like you do your application code as well. Thank you very much. I'll now hand over to Raj Wilku from Just Eat, who will take you through how they're using CloudFormation for their continuous integration and continuous deployment work on AWS.
Thanks, Steve. Hi all, I'm Raj from Just Eat. I'm going to expand on Steve's last slide and talk about how we continuously deploy new and enhanced functionality to all our end users. But first, let me introduce you to the Just Eat platform and some of our challenges. When you look from the outside, Just Eat looks just like any other e-commerce website. We have a product catalog, a shopping basket, order processing and fulfillment. But we have some interesting and unique challenges. If Amazon takes a couple of hours or days to deliver your items, it's fine. Some companies charge you extra for next day delivery, but we have to ensure that your food gets to you within 45 minutes to 1 hour so that you can enjoy it while it's still hot. The Just Eat platform is basically a real-time message delivery and notification platform with hardware in over 20,000 restaurants in the UK and over 40,000 worldwide. We have an unforgiving demand curve where our peak traffic is 10,000% times of our off-peak traffic. We have development teams in 3 cities and we release over 130 times a month. Most interesting of all, the platform runs mainly on Windows. So how do we build software of high quality to deliver that fantastic takeaway experience? We have automated the setup, testing and deployment of every part and every layer of our infrastructure. We have found that TDD, continuous deployment and immutable infrastructures has worked really well at Just Eat. Simply replacing rather than updating parts of the system actually makes deployments less complex. Since we replace parts of our infrastructure many times a day, we are quite comfortable with releasing changes. This workflow helps to improve our service really quickly, and since we can experiment, make changes and roll back quickly if they don't work, innovation just becomes part of every experiment. Once deployed, the only way to change that part is to deploy again, so we get predictability. We deploy in auto-scaling groups and auto-scaling on by default. There isn't a concept of a server, it's a collection, and one can disappear at any time. Because it's all scripted and in source control, we can stand up multiple production-like environments that look the same. And because we have seen value in being lean and pushing little pieces of functionality that provide instant business value, we're always looking to speed up the deployment process. With a large development code base, we've split our platform out into components which are deployed separately. You can have parallel deployments of several components at once. Each component is defined by a single CloudFormation template which contains everything that component needs. The actual build artifacts come from S3 and an instance will bootstrap itself using CloudFormation Init using a pre-baked AMI. This works really well with scaling out as well. Everything we need is available in one artifact. We use both pre-baked AMIs and CloudFormation Init to bootstrap an instance. The more you put into an AMI, the quicker the machine boots. However, baking an AMI takes time and we want to move faster than the time it takes to bake an AMI. So we are continuously evaluating what goes into an AMI. Ideally anything that is static, Windows features, static dependencies, settings that don't change all go into the AMI. The CloudFormation Init just installs the app and sets up additional services that have been pre-installed. We build up the CloudFormation file from multiple YAML and ARB files. This works just like an HTML templating engine. There's a layout master and then partials and conditional includes that build up the final file. You would not build a website today by editing each HTML file separately. You want a standard layout, look and feel across your website. And this works the same for CloudFormation. With lots of features, you want a standard way of creating these files and you want code reuse. Also, for someone new to AWS at Just Eat, they can just easily pick up and make changes to these files. Since we also want to be able to build a new environment anytime, we've adopted convention over configuration so that you do not need to specify a lot of parameters to create the environment within QA. Each component has its own source control repository. The CloudFormation templates also live within its own repository and is shared. Any changes to the CloudFormation templates is tested in a production-like environment. Any changes to components is tested within the CI process. The build artifacts are pushed to S3. The final CloudFormation JSON is generated by JustDeploy, which generates the templates and orchestrates the deployment, sending notifications into HipChat for the development team. The instances are built and are bootstrapped from S3. Same happens with our AMIs. We define what goes into our AMI in a declarative way within text files, and that lives in source control. When an engineer clicks a button, our CI server via our bakery picks the latest Windows or Linux AMI from the Amazon Marketplace and bakes a new AMI. This AMI is tested and a manual step takes that AMI and inserts it into our YAML file, which is used in CloudFormation. So what's next? We don't like manual boring steps, so we're going to kick off an AMI build from an SNS notification which is sent when the marketplace is updated. We also want to select the last tested AMI automatically. This can be done by the new feature in CloudFormation, Lambda. Other bits we're working on failing over to a secondary region. We have some components that fail over built using SNS SQS, and we're working on improving that as well. We have an open source product called Just Saying, which is kind of a service bus library that's built on SNS and SQS and implements a couple of patterns that allow you to recover from region failover. Finally, we are working to publish all our tools as open source and give back to the community and drive innovation. Thank you. Yes, we're recruiting too, and if you're interested in working at Just Eat, interested in the technology we'd be talking about, please go to http://justeat.com/jobs. We're always recruiting. Thank you very much.
Thanks, Raj. So thanks for joining us for this session from the AWS Summit London 2015. We really appreciate you giving us your time to learn more about Amazon Web Services. If you want to stay up to date with new services from AWS and other AWS news, please follow us on Twitter at AWS Cloud. You can also stay up to date with the latest news from AWS here locally in the UK and Ireland at AWS UKI on Twitter. If you want to continue to learn more about AWS, you might also be interested in the regular webinars that we're running throughout 2015. You can find more details on these in the video description below. You can also find a link to the slides from this session on SlideShare in the video description, and you can download a PDF version of the slides from there. Thanks again for joining us.